Right, this is problem 2.6.15. We have the perimeter of a basketball court is 102 meters and the length is 6 meters longer than twice the width. And we want to know what are the length and the width. Okay, so the first thing we should do in a problem like this is give ourselves a picture. And we know that basketball courts are rectangular. And there's going to be a length and there's going to be a width. Now the distance, the perimeter is the distance around an object. So if we were to look at summing the values of each of these sides, that would be equal to the perimeter. And so they tell us that the perimeter is 102 meters. And the formula for perimeter, taking into account the fact that we're summing all of this, because this is length also and this is width also. So the formula for perimeter is actually 2L plus 2W. So we're going to need to work with that formula in this problem. Okay, so they also give us some other information here. They tell us that the length is 6 meters longer than twice the width. And frequently what we want to do in math when we're working with these word problems is we want to actually convert the words into mathematical symbols. So the word length here, that's referring to our variable L. The word is in math is frequently an equal sign. And then we have 6 meters longer than. So 6 longer than could be represented as a 6 plus. And twice the width, if you take twice something, you're multiplying it by 2. So twice the width would be 2W. Okay. So our second equation here would look like this. Length is equal to 6 plus 2W. All right, now we actually have in this equation right here, we have 3 variables and we can't work with it in that form. So we need to start substituting values in to see if we can get this into an equation that just has 1 variable in it. If it has 1 variable, then we can solve it. Okay, so what I'm going to do is I'm going to take this 102 right here and I'm going to drop the unit of meters and we'll add that back in later. And I'm going to plug that in for the P. And since these two things are equal to each other, that I can do that and not change it. Okay. And then right here, it's just saying that the length is 6 plus 2W. So I'm going to take this entire expression here and plug it in for the length right there. And we need to recognize that this 2 is multiplying the length. And so if I plug in an entire expression, that 2 is going to multiply the entire expression. Okay, so our new equation is going to look like this. 102, that's the 102 going in for the perimeter, is equal to 2 times the length, but I'm plugging in for the length, 6 plus 2W. And then we have our plus 2W off the end there. Okay, so you can see now that we have just one equation in one variable. And that's what we want in order to be able to solve this. Okay, so we're going to solve it like usual. We'll start by distributing the 2. And so this becomes 12 plus 4W plus 2W. And then we want to collect like terms on this side. So we've got 6W. And now we're going to subtract 12. So we've got 90 equal to 6W. And then we're going to divide by 6. Okay, so W here is 15. All right, let's add our units back in. So that is meters. And they also wanted us to find the length. And so in order to find the length, once we have the width, we're going to take this value and plug it back into this expression right here because we have a relationship between length and width in that expression. So to find the length, it's going to be 6 plus 2 times W, and we already found that the W was 15. So the length is going to be 6 plus 30, or in other words, 36 meters. Okay, and that's it in that problem.